Hi everyone. Before you watch this video, you might want to watch part 1 first. This is the one with different arguments, and this one is more complex argument here. So from the first part, we know that we're going to solve for theta equals -1. Cosine of theta is -1, so we know theta is pi. Okay, and then we're going to go ahead and write our general formula, which is 2k pi. And then we're going to set this, we want this whole thing to equal pi, because we know cosine of pi is -1. So we set it to equal that. Now, we do want to solve on this side from 0 to 2 pi. Now, you just solve for theta. So we're going to first add pi over to 2 to both sides. And when you do that, you're going to get 2 theta equals pi plus pi over 2 plus 2k pi. Now that's going to equal, because you can call this 2 pi over 2. That's going to be 3 pi over 2 plus 2k pi. Now, you're going to divide both sides by 2, so you get theta equals 3 pi over 4 plus k pi. Now, we want all solutions between 0 and 2 pi. So I already know when k is 0, that knocks that out, so we just get 3 pi over 4. And we need to go to 8 pi over 4, because 8 pi over 4 is 2 pi. You can write it like that if you want. Alright, so let's let k equal 1. So we would get 3 pi over 4, and I'm going to just add plus 4 pi over 4. Because 4 pi over 4 is just pi. And that gives you 7 pi over 4. And you know we can't go any higher, because we have to stop at 8 pi over 4. And that's simply that. Alright, the next one, we're first going to solve sine of theta equals 1. We know that that is at pi, let's see. We know that that's going to be pi over 2. And I'm going to go ahead and write this as 2k pi, and my general formula for that. So we want this whole thing to equal pi over 2. So I'm going to set it to equal that. 3 theta plus pi over 18 equals pi over 2 plus 2k pi. Now, I'm going to go ahead and subtract pi over 18. In common denominator, we would get 3 theta, need 18 here, so that would be 9 pi minus pi over 18 plus 2k pi. So what we're going to get is, I'm just simplifying this, you get 8 pi over 18, which equals 9 pi, it equals 4 pi over 9. So I'm just going to change this, when you subtract that, to 4 pi over 9. So this is going to be 4 pi over 9 plus 2k pi. Now divide everything by 3, and you get theta equals 4 pi over 27 plus 2k pi over 3. Remember that k is any integer. So we know when k is 0, we're going to have 4 pi over 27. Alright, let's try k equals 1. If you try k equals 1, you're going to get, I'll move it right in here. you're going to get theta equals 4 pi over 27 plus 2 pi over 3. That's going to be 4 pi over 27, and my common denominator is 27. That's going to be 18 pi. So that's going to give you 22 pi over 27. And how far can we go? Well, we have to go from 0 to 2 pi. And with 27 being our common denominator, that's going to be 0 to 54 pi over 27. So it looks like we can go some more. So this was k equals 1. Let's try k equals 2. When k equals 2, we get theta equals 4 pi over 27 plus 4 pi over 3. That gives us 4 pi over 27 plus 36 pi over 27, which gives us 40 pi over 27. I'm running out of room, but if you do, this was k equals 2. If you do k equals 3, it's going to be too big. It's going to be greater than 54 pi over 27. So we are done. Okay, here's another one. We know that if this is our theta, we want our theta to be pi over 4. So I'm going to set this to equal pi over 4 equals pi over 4. And remember, the period for tan is just k pi. So the first thing we're going to do is subtract, or add, sorry, pi over 3. Whoopsie. So we have over 4 plus pi over 3 plus k pi. And what you're going to get is, actually this was written down wrong. This should have been a plus. So if that's a plus, this is a plus. So this should be a minus. Sorry about that. So what you're going to get is theta over 2 equals negative pi over 12. That's just getting the common denominator stuff here, plus k pi. Now multiply everything by 2. So we're multiplying this whole thing by 2. And you get theta equals negative pi over 6 plus 2k pi. Now, we want our answers or solution set to be between 0 and 2 pi. And if you notice, if we put in k equals 0, we get theta equals negative pi over 6. That doesn't work because it doesn't follow in our domain here. So I'm going to cross that out, and I'm going to try k equals 1. For k equals 1, we get theta equals negative pi over 6 plus 2 pi, which is going to be 12 pi over 6. And that gives us 11 pi over 6. And if we have k equals 2, we get theta equals negative pi over 6 plus 24 pi over 6, which gives us 25 pi over 6, which is too big, because this would be between 0 and 24 pi over 6. So we only have one solution, which is 11 pi over 6. We have to disregard this one and this one. Okay, the last one, we're going to set this to theta, and theta would be for 1/2. We would have theta equals pi over 3, or 5 pi over 3. So we want theta to be this or that, so we're going to set that, this argument to pi over 3 plus 2k pi, and we're also going to set it to, let me just do this one first. So when you do this, you're going to get theta over 3 equals pi over 3 plus pi over 4 plus 2k pi. And I'll do this side over here. This one would be theta over 3 minus pi over 4 equals 5 pi over 3 plus pi over 4 plus 2k pi. Now, for this side, when you simplify, you're going to get theta over 3 equals 7 pi over 12 plus 2k pi. And this one's going to be theta over 3 equals 23 pi over 12 plus 2k pi. All right, then multiply through by 3, and you're going to get theta equals 7 pi over 4 plus 6k pi. And this one's going to be theta equals 23 pi over 4 plus 6k pi. Now remember, we have to go from 0 to 2 pi. Now if k is 0, we only have 7 pi over 4. If we put 0 here, this right in itself is too big. So that cancels that out. Also, when you let k equals 1, that's going to be, just that in itself is bigger than 2 pi. So we only have one solution, and that is all. Thank you. Have a nice day. The next set we're going to do is solving trig equations that are quadratic in form, where you're going to have to factor. Thanks. Bye-bye.